Okay, the next question is question number 8. And it says use the formula omega equals theta over t to find the value of the missing variable. And so this is very straightforward because we're given the formula and we're given that the angle is theta equals 2 pi over 5 radians and the time is equal to 10 seconds. Okay, now what this is really saying is this is a formula for angular velocity. It's saying that if you go a certain number of radians in a certain amount of time, then you've got yourself a certain angular velocity. So we just have to plug into the formula to find the angular velocity. We plug in theta is 2 pi over 5 divided by 10, which is the same thing as 2 pi over 5 times 1/10. You might remember keep, change, flip. And then that gives you, multiplying numerators and denominators, 2 pi over 50, which is the same thing as pi over 25. And as far as our units go, I could have put radians in here, okay, and seconds in here. So this is radians per second. Let's go on to problem number 13. Okay, so problem number 13 is similar. We're given a formula. V equals R times omega, and we have to find the value of the missing variable. But let's understand what this formula is saying. This is saying that the linear velocity is equal to the radius times the angular velocity. So another way of saying this is that if you're thinking of like a phone, well, I don't know how many of you know phonographs anymore, but you've probably seen a turntable, a record that's going around and around on a turntable. I think those things are still used in certain settings. Okay, let's take a turntable, and you've got the disc or the record is spinning around. Let's say it's spinning around counterclockwise, and it's going at a certain angular velocity, and let's say that angular velocity is fixed, so that you're going, let's try to keep this sort of simple. Let's say it's going pi over 2 radians per second, so that's 90 degrees. Okay, so that means that something that is at the top of this circle is going to be over here on the left of the circle after 1 second, because it's going pi over 2 radians per second, so it's essentially rotating 90 degrees a second. But notice what that means for linear velocity is that something on the outside of the record is going to go pretty fast. Okay, it's going in this entire distance in a second, whereas something that's very close to the center of the record, like here, is going to go a lot slower because it has a much shorter distance to travel in the same second. Okay, and in fact, that is the linear velocity, how fast it's moving with the record on the record relative to the turntable is a linear velocity. It's moving a lot faster on the outside of the record than it is on the inside of the record. And in fact, at the center of the record, it may be spinning around, but it's not moving anywhere. It's staying in the same point. It's just rotating. Okay, but it's not moving anywhere. So when your radius is 0, your linear velocity is 0. And the higher the radius is, the higher your linear velocity gets. So we sort of need to understand why we're practicing this formula. So let's go ahead and take a look at number 13. We're given that the radius is 12 meters, and we're given that the angular velocity is 2 pi over 3 radians per second. And we've got to find the missing variable, which in this case is going to be the linear velocity. So we simply plug these things in. 12 meters times 2/3 radians per second, and we're going to get the units meters per second. 2 cancels into 3 to give us 4, so we're talking 8 pi meters per second. Okay, so that is the answer to number 13. Let's look at number 17. Here we're given the linear velocity is 107.692 meters per second, and we're given that the radius is 58.7413 meters. And so again, our formula is V equals R times omega. The missing value here is omega. So we've got to solve for omega. We can divide both sides by R, which will give us omega equals V over R. So this is the form that we need to solve for omega. So let's go ahead and divide V by R. That gives us 107.692 divided by 58.7413. And that is, let's see what we get when we do that division. Clear some of this up. 107.692 divided by 58.7413. And we get 1.8333 repeating. And the question is, how many significant digits do we need? Well, let's see how many significant digits we have here. 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. So I'm hoping that they want 6 significant digits. So that would give us the omega equal to 1.83, and then let's say 3, 3, 3, 3, and then another 3. We round that 2 up. So I'd say it's 1.83333. And what would be the units here? Well, the angular momentum in these kinds of formulas is always radians, and our time is seconds, so this would be radians per second. So that is the answer to number 17.